Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss a problem on turbulent flow in pipes. So in our previous video lectures, already have discussed several derivations regarding this turbulent flow and the smooth pipe and drop pipes and average velocity. So all these things we have discussed previously. So let's see a problem on the turbulent flow. So the question here is given for turbulent flow in a pipe of diameter 300 millimeter, find the discharge when the center line velocity is 2 meter per second and the velocity at a point 100 millimeter from the center as it is measured by a pitot tube is 1.6 meter per second. So let's consider a pipe. Through this pipe, actually the liquid is flowing. So let's consider this is the pipe is there, and this is the center line of this pipe. Okay, and the fluid velocity which is flowing here, let u, and we know that at the center line the fluid velocity is maximum, and at this wall of this pipe it will be minimum. So the profile will be like this. So here it is given. If you see the question, let's write down the data given here. So the data given is diameter is given d equal to 300 millimeter given. So d equal to 300 millimeter. So you can write this one in terms of meter. That means 0.3 meter. And here we can write the r value. This is nothing but 0.15 meter. Okay. So here we need to find out the discharge. So discharge, let q need to be identified. I'll tell you what. Now, as I told you, this is the pipe is there, and diameter of this pipe is total this, and this part is the radius one. This is the radius part, and here the velocity is given for the center line velocity is given. That means the maximum velocity is given. So you can write u max. U max is in the center line. So you can write u max equal to yeah 2 meter per second. Okay, now the velocity at a point 100 millimeter from the center. So this is the center. Okay, so from here 100 millimeter is there at that point, or you can take it to this side. The any 100 millimeter you can take it from this center point, and that point velocity is given 1.6 meter per second. So the velocity at a point of at radius r equal to 100 millimeter equal to, here r equal to, we can write 0.1 meter. The velocity equal to 1.6 meter per second. So these are the data are given in this question. Okay, we need to find out the discharge. So discharge equal to, we know that area into velocity. So this is the continuity equation or the discharge equation. So the velocity what we need to consider here, actually area into the average velocity need to be considered. What is the average velocity of this fluid in this pipe need to be considered. So average velocity equation we have seen in the previously. So actually in that average equation, like average velocity equation, we have a value of u star is there, that is shear velocity. Again, to find out the u star, we need to go for the velocity of at any point of the in the turbulent flow. And so for that, what I'll write, so this one we can write at r equal to this value, and we can find out the value of y. The value of y is nothing but this one y, and this is r, we can say. So y equal to capital R minus small r. So this is nothing but 0.05 meter. So now the velocity in terms of center line velocity, already we have derived previously. So let me write that equation. U max minus u divided by u star equal to 5.6 0.75 log 10 divided into y by r by y, reverse of this. This is the equation actually we previously we got this. Now here if you see in this equation, u max is there, u is there, u star is not there, remaining r is there, y is there. So what we'll do here, we'll just put all this value what we have, and we can find out the value of u star here. So u max equal to 2, maximum velocity, u is the 1.6, and this is u star which is unknown. Now you can write 5.75, and this is log 10 r by y. So r equal to here what, 0.15 divided by y equal to 0.05, bracket close. Now what is the unknown here? U star is the unknown, we can easily identify. So what I'll do here, I'll just write u star one side, this one. Suppose let me take this u star to this side, and I'll keep this v star one side. So other side what will get, 2 minus 1.6, so that is 0.4 divided by this value. I'll just multiply with the help of this calculator. I'll take this calculator here. Now this 0.15 by 0.05, that is nothing but 3. So log of 3, this one, multiply of 5.75. So this is 2.74. So that means u star equal to 0.4 by 2.74. So again we can write this is 0.4 divided by 2.74, 0.145. So this is 0.145 meter per second. So this is the u star value, that is shear velocity value. Now we required actually this average velocity here. So now again one more equation I'll write in terms of which will give the relations of velocity at any point and the average velocity. So that equation actually let me write u minus u bar divided by u star equal to again 5.75, and this is log 10, and this is here it is opposite, y by r plus 3.75. So this is the equation between the velocity at any point and the average velocity. Okay, now in this equation you can see, you can observe the velocity is given, that average velocity is unknown, that means it is not given. U star we have identified here, y value known, r is known, we can find out. Okay, so let's write down u equal to what, 2 minus u bar divided by u star is nothing but 0.145, I hope 145, yeah, 145. So this equal to 5.75, this is log 10 y by r. So here actually y equal to r, okay, will the u becomes u max, the u become u max, because here y by r is there. Now so because see, this is the central line and y is the at this point. So y at this point we have taken, at any point we have taken for this one. So when the y will be maximum, that velocity will be maximum. Now when y equal to r, the velocity u equal to can be maximum at this point. So what will put, u max minus, this is u max minus u average by u star equal to 5.75 log 10 bracket, in place of y let put r value, r by r plus, here you can give the value of how much is the 3.75, I hope, yeah, this is 3.75. So now you can, it will be cancelled, r by r will be 1. So log this term will be there. So what I'll do, I'll just write this side, this log 1 equal to 0. So this one we can write 5.75, this term will be totally 0. Okay, so now this one we can write 2 minus u bar equal to this is 0, no need to write again, otherwise already 0 you got, then y, this is 3.75 multiply of 0.145, and this one we can write again u bar equal to, let multiply this 3.75 into 0.145 equal to 0.54, yeah, 0.54 minus 2 I'll do, minus 2 equal to 1.45, so positive 1.45. Now 1.45, this is meter per second. This is about the average velocity. Okay, now for this I require the average velocity to find out the discharge. So what I'll do, I know that q equal to area into average velocity. So area is nothing but pi by 4 d square into average velocity. So pi by 4 into 0.3 square, diameter 0.3 into u bar. U bar we got just now, this is 1.45. Now just take the help of this calculator. This one, let's multiply of 0.3, again 0.3 multiply of pi equal to this one divided by 4. So 0.102, 0.1029. You can write 0.1029. Here actually the minus value is coming because I have subtracted the value from 0.5 to 2. That's why the minus came. That is actually positive. Okay. So now this one we can write. This is meter cube per second. So this much discharge of fluid will be there from the pipe. So I hope you understand this question. What I have done here is very simple. This is the final answer of discharge. So question is given very simple. Turbulent flow is there in a pipe. This is the pipe is there. You can write, this is the pipe flow and the fluid is flowing like a turbulent. Okay, and diameter is given 300 millimeter. We need to find out the discharge. So what is the discharge from here? That need to be calculated. Q need to be calculated. When the center line velocity 2 meter per second is given, velocity at a point of some distance r smaller is given 100 millimeter, that velocity is given. So the question is very simple. We need to just remember this formula and this formula, because we require finally the u bar. So u bar is related to this formula, and here unknown is there u star. So u star we can get it from this equation. Maximum velocity and velocity at any point, and this u star. Once you find out this one, then we can go for this equation, and finally we can go, implement the value in the discharge equation. Okay, so I hope you understand this problem solving. If you have any kind of query and doubt regarding this, you can give a comment on the comment box. Thank you all.